This conference will now be recorded.
All right, good afternoon, everybody. Today we have a privilege of having the Reverend Hattrick, that is James Ball, one of the founders of HackMiami. James is truly a person that I respect and admire, and I had the privilege of being his friend. James, for me, is an American hero. James is an original terrorist fighter, freedom fighter. He's very humble, and he will never, tell you all his adventures. But he's incredible, and maybe one day I'll just sit with him and we'll talk about some of the amazing things he's done. And you get to see how a person that really truly believes in what he does, how he helps others, and he simply doesn't say anything. It's not like other people that are boasting about stuff that they truly don't do, by the way. So thank you, James, for giving us this time. You are one of the pilots at HackMiami. You are one of the founders. I know you from now quite a bit of time, and I'm very happy you're still with us, even though you're not longer in Florida. You're in the West Coast, and we're happy to have you here. And without further ado, this is James Ball.
Hi, everybody. Thanks for that fantastic introduction, Rod. That was very nice. Let's see. So, this is going to be the red teaming the cloud. Basically, this presentation. I decided to do this presentation because I've been getting a lot of requests and engagements where they wanted me to go attack either an on-premise enterprise cloud environment or like a full base IP range in the cloud, or also Amazon instances. So basically, I've been getting a lot more requests to attack more cloud infrastructure. And so during this time, getting this request, I decided to do the most recent SANS training on the on cloud penetration testing. And to my surprise, and also to my surprise when I was doing the engagements, a lot of the methodology that I've used for web application hacking, basically the other type of hacking, basically follow through to this environment as well. So it was a pretty much easier pivot to go from web application hacking, which was my forte at first, into this. So I'm going to keep it high level. I'm not going to show any demos or anything because I don't really have any targets live that I can legally show you right now. But and I will keep this focus on AWS primarily. However, Azure, Microsoft Azure Cloud, that's also very similar to this, as well as Google Cloud Computing and Alibaba. So what I'm going to be discussing here will work across all the different types of or all the different vendors in cloud computing. But this will be primarily with AWS. Now, when you're going to be doing cloud computing or cloud-based penetration testing, you are going to be using the tools associated with the environment. So when you be testing Amazon or AWS system, you'll be using their AWS client command line interface or their own tool. And most of the attacks will be based on your knowledge of those tools itself. So that is something that is also quite interesting, that the tools that you'll be needing to do a lot of the privilege escalations will be the built-in tools. So if you do manage to compromise, say, an internal system, you wouldn't have to be worried about installing extra tools, because more than likely these tools will probably be in one of those systems. So here's another brief introduction that I wrote into the presentation about me. You know, I've been here for a very long. I've been doing this for a very long time. I really couldn't give a better introduction than Rod has given to you guys earlier. But I will go into the types of things I've been into recently. I did mention I've been going to cloud computing recently, but I'm also a subject matter expert in web application testing and API testing, as well as single sign-on technologies, which goes very well into cloud-based testing. So, as I said earlier, the cloud is being adopted by many industries, and many industries are going to go fully based into the cloud. Now, when I mean the cloud, I'm also saying Azure and AWS. You can even see it on application on software as a services, such as Office 360. That's a type of cloud-based thing, infrastructure. That's considered a software as a service. So one thing we would go into is the types of cloud-based services that we can test and the scoping around them. Oops. Okay. So yeah. So in this slide, I described the types of services that we see in the cloud. As I mentioned earlier, software as a service. Here you'll be only able to attack the instance of the organization's implementation. So you'll be attacking, say, Tesla's instance of or Office 360 as opposed to Office 360 itself. So now we go to platform as services. These are things that we see that allow developers to code in an existing environment. And when we have these types of tests, you are expected to stay within the containerized area of that instance. So basically, if you're testing, say, something like SharePoint, you'll be only testing the, say, tesla.sharepoint.com or something like that. And the basics understanding of this is that when we're testing cloud infrastructure and cloud environments, we're going to have to make sure that we're only sticking within the client's or the target organization's instances of it. We generally would not have the permission to actually go, say, attack Amazon.com itself or Azure, the instance itself, but we more than likely will be attacking the implementation of these instances. The last method here I have function as a service. This is basically AWS Lambda and Azure functions, virtual functions. These are basically one-time things that can be spun up and down, basically when they're executed on demand. And a lot of these functions have permissions that are higher than the normal user permissions. So we'll be able to potentially pivot from those functions as service or these one-time use functions onto another system. Okay, so here's I go into when we're testing the software as a service. I have here the Salesforce, OS 360, Dropbox. It basically is explaining the types of access controls that we have to focus on the tests. Go to the next slide. So this basically what I said earlier in other slides here, where it's basically platform as services on the containerization of the application. So we're going to try to stay within our own containers when we're doing these types of testing. So here's infrastructure as services. These are the ones we're attacking: the virtual machines, the storage devices, storage services, and blocks such as blob services. What would be when we're testing those things? We'll be testing basically how the client or how the target configured their the permissioning to or access to said storage services. Now, Amazon Web Services allows for testing of freely testing of their services as long as they stick to the client that you're testing. So you stick to your own platform and your own implementation of it. They allow you to test it all you want. With Azure, however, if you want to test anything related to Microsoft services, you will have to send them a notification email. But AWS will allow you to test mostly all of their services. Their main restriction for all types of cloud-based testing is they do not want you to do denial of service attacks where you affect other customers and their own infrastructure, and they also do not want you to do something where it will take up too much resources and then eventually cause another outage. So their main concern is that when you do testing on a cloud environment, that you're not messing up other people's implementation of it. So here's the stuff that Azure, like I said, they allow you to do. They do allow you to test virtual machines and also the security monitoring of it. But they want you to send a notification. And the same thing applies for Azure and AWS. When you're doing a proof of concept attack, they don't want you to drop like a command shell or anything malicious on the box, or they don't want you dropping ransomware or anything on it. They want you to basically do proofs of concepts demonstrating that you can access the information. Here I go into some information on types of containers that are packaged. This is basically going over run C. This is what you see in mainly the Linux environments. Docker requires this to run. So when we do things with Docker, you'll notice that they do have to use run C with their containers to run. Excuse me for a minute. Now container D is another container function. It's basically a daemon that runs in a real time. They use a protocol gRPC that you see in the background, and that's how they communicate with each other, with the services via on the containers. You'll probably see gRPC calls when you're doing Wireshark inspecting of network traffic using Wireshark. But for the purpose of what I'm saying here, or this presentation, this is basically letting you know what the technologies are in containers. But for on this presentation, we will not be exploiting this aspect so much. So what I mentioned earlier today is that when I started doing the cloud-based penetration testing, I was actually surprised about how very similar it is to web application testing, to the point that there were a few slides in the training itself that referred you to go take the web application training as well as the advanced web application training, which I've done already. So, and the things that they demonstrate in a lot of these trainings are things that when I try to do in the real world are not as prevalent anymore. About 2 years ago, this was more prevalent. You'll be able to see open Mongo databases and open Redis databases, but not so much anymore. But it's still always good practice to always check for it. even though there's bug bounty programs and there's tons of internal teams, there are still you still might get an instance of a rogue of basically of a developer spun up something that maybe forgot to spun down, and that could lead to a pivot into another instance in there. But from what I've seen over the last few years, when it comes to infiltration of enterprises, um, it was either done, it was mainly done via phishing and social engineering attack. I would say about 90% of 95% of the infiltration done of enterprises nowadays is done by a phishing attack or a social engineering attack. Um, I have seen other types of attacks where they exploited the APIs of many of these services. Uh, I myself was able to exploit APIs of IAM, the Identity Access Management protocols, which we'll go into later down the slides, to get basically through basic API calls via over permission tokens or sessions that are being sent in the API. But when we're first starting out doing these enterprise tests or very large cloud-based testings, you may not find things coming at you at first. You may scan a very large pool of IP addresses, and they will not ping back to you because they've already been patched up or not. So so what we're going to be going into mainly now is a lot of these things will be is if you already did post exploitation after social engineering on an employee, or if we're able to gain information via an exposed API or misconfigured API or other web vulnerabilities. So the tools that we'll be using for cloud-based testing are basically the same tools that we'll be using for web-based testing. Burp is my favorite tool. I use it for every test. It's a very a robust tool. Burp is a proxy tool that you'll put in between the client and the server, and it'll intercept the traffic from the your client, which will be your laptop or the browser you're using, into the server. And Postman is basically a client used to make API calls. When developers develop APIs, they often use Postman scripts or Postman to test the API out without actually having to develop a full front end for it. So Postman is basically a way to do a front end for APIs if you do not have an application for it. I like to still use Burp in lieu of Postman when doing these tests. In my experience, when I was using Postman in the past, Postman will oftentimes add their own encoded value, or they will correct an encoded value. So if I were to put a %27, which is the HackMiami logo, into the Postman script, instead of sending the correct 20, instead of sending %27, it may actually just send the apostrophe itself. Whereas Burp, I can guarantee it that it will not alter that that URL encoding when I send it. I've only had that happen a few times in the past, but that's a caveat I've had when I've used Postman. Now Masscan, and it will be using for when we get an IP address range that contains thousands or even millions of IP addresses. Oftentimes this will also be internal IP addresses too. That if it's an enterprise environment, we'll be testing a pretty long range of VMs and IP addresses there. So we're going to use Masscan because Masscan will be able to scan all of these in a timely manner. The downside of using Masscan is that you'll be sacrificing accuracy for speed. So what I like to do is I would like to use mass scan to go scan a large range of IP addresses first, and then get the results from mass scan, like any host that it finds that was up, and any ports that I find was up, and then throw it into Nmap, because Nmap will also have extra scripts for it, such as I'll go into it later on. If I find like a Mongo database, I could use Nmap to verify that the Mongo database is actually there and I could access it. As I mentioned earlier, if you're going to do Amazon Web Services or Amazon cloud-based testing, we'll be using the AWS CLI tool. And for Azure, they have the Azure command line tool. And for recon, we're going to use open source tools, especially at a scale. One tool that I really like to use is crt.sh, which is a great way to enumerate subdomains. And I'll get into that, I believe, into the next slide. But Census.io is like another Shodan. It's based, they already scan the internet, and if you put in IP addresses, they'll display what ports that they were able to detect open beforehand. Robtext.com is something I've used to map out large ASNs or large network areas. They can also provide other subdomains or other hosts or host names or domains that are rely on the same host. Now, I could talk about these tools and go into how to use these tools, but I'm pretty sure that you guys could find the research into using these tools yourself. There are a lot of there's a lot of documentation on how to use Burp. There's a lot of things out there for all of these tools. So I don't feel it's necessary for me to go into how to use typical calls and stuff. There's a lot of documentation out there. And I'm sure if anybody have done any training or any like information security, you've probably heard of some of the tools. One being at least Nmap. That's been around since the Matrix. So this is still a tool that's being used today. So I mentioned crt.sh. Now we're using the certificate transparency tool. The certificate transparency was a way for that browsers and a way for browsers and clients to know that the certificates that are being presented on the websites are actually their certificates and not a spoof certificates or malicious certificates. So there are several certificate transparency records out there that we can go look through for certain domains. One of them is crt.sh. Facebook has one of them as well. But we're going to use crt.sh because it's free, it's online, you can use it anytime. Okay, so here is an example. Okay, got a comment? GoBuster is good, but yes, there are several tools that are definitely a lot more faster now. One reason why I like these, I mentioned GoBuster and DNSRecon.py is because one of them was written in .go, one of them was written in Go language, and the other one's written in Python language. So they're usually universal on all operating systems. So that's one reason why we like when we use we like to go show out scripts written in Python or Go languages. So here I gave an example of how I used I tried to enumerate some subdomains of Tesla.com, and I used the CRT, the certificate transparency site, and I used the wildcard of the % there in front of .tesla.com. Now, the reason why I put the wildcard .tesla.com is because if I just said wildcard tesla.com, it'll pollute the results with some that could have something with before the word Tesla in it. So if I put wildcard.tesla.com, to make sure that I get more subdomains out of it. And here we can see you get more subdomains out of it. We can see there's powerhub.energy.tesla.com, gridlogic.energy.tesla.com. The list went on pretty long, but here I just want to show you what this could look like and how you can enumerate other subdomains by using this certificate transparency tool. I forgot to, I didn't mention in that last slide, but you can also pair up DNS Recon, the Python script, with the results you get from crt.sh to get even more subdomains. And then then what I would like to do is I would use GoBuster to get the director, basically the directories afterwards. See if we can enumerate any directories after the domain. So other things we want to look for when we're exploring enterprises or the cloud-based stuff is that we're going to look at the GitHub repositories. I myself seen in the past where developers will put up a project they're working on the external Git, and then they'll have SSH keys in it or hard-coded credentials. Oftentimes their own credentials for their own work environment, such as Active Directory credentials. And they might even realize that they put these credentials in later on, and they'll go on to go back into the Git and remove it. So I've seen in the past that even though they removed the passwords, they forget to go back to old commits. And if you go back to the old commits, you may see some credentials leaked in there. Oh, here's where I mentioned where I could use the DNS Recon with IRS. So here's where I mentioned I go more into the other services in more detail. The Census.io, Shodan services. I'm sure you guys have seen these services already, so I won't go in too much on them. Okay, so once we scan things, we might see here are some databases that are usually sent to like AWS functions or cloud functions, and we'll notice that they are we'll see port 27,001. We'll also see the Redis port 6379, and these were often released out there, not intended to be externally facing on the internet. So a lot of times these databases may not have proper authentication or authentication at all. So once we find these, we can use Nmap or other scripts to try to connect to these databases. So now we're going to go into trying to we're going to talk about the Amazon's AWS implementation of their cloud services. So Amazon has Amazon AIM, which is used for authentication, authorization. It's the identity access management mechanism of it. It handles the permission policies, allows access via API to various parts of the net or the system or the services. They offer group permissions and they offer federated services. One thing we're going to go into here is how IAM is both has role-based access controls and attribute-based access controls. So here are some quirks with the access controls and this was good. This and AIM, excuse me. So one of the things that AIM supports is a resource policy. meaning that if you explicitly give the permissions to the users, say you explicitly, in this example, I explicitly gave Jimmy the permissions to list read write to the S3 bucket, but Sarah, she don't have permissions to the S3 bucket. However, the resource S3 bucket can have permissions on it themselves. So even though I as administrator could explicitly have told Sarah that she did not have permissions to this resource, the resource could have been somehow provisioned to have this on to have Sarah on a resource. So what can happen oftentimes is say Sarah herself moved on to another department or another division, and they took the resource off her name, but it's still the permission off her name, but the resource is still allowing for the permission for her to get into it. So here are some other things like service policies. Lambda functions, they have these policies on their own things, on their own instances. And so when we have these policies of service, we may be able to use one service as a pivot point to interact with another service function where the user does not really have access to that function. So if say there's a function that makes a call to billing, it's like a one-time use function. Now a user may have access to that function, but doesn't necessarily have access to billing. So maybe a function could be, maybe a user could leverage this function to access something else. So this is one of the ways these permissions or these functions could be a way to pivot to another aspect of the cloud. So here is one we have for attribute based control. So AWS has a tag system. So in this example, we have user Jimmy. He's tagged with the team. He's tagged with the group, team, and Dolphins, where Sarah's team is in Seahawks. Now the resource is here is tagged with only to allow the Seahawks team. So it's already going to deny my team, but allow Sarah here. One good thing about attribute based policy, the way administrators use them, is that if they want to remove a lot of policies or add a lot of policies to a certain user or a certain resource, they could just add a tag there. And if the tags are not there or not, if the tags are there, they'll let them in. And if the tag is not there, then they won't let them in. So this way, say if in the last example where Sarah went to another department or something, regardless if she went to another department, if the tag is not there, then that resource will not have let them in. Another thing that AWS has is user versioning. So say Sarah went to another organization again and went to another department, and now but her user still had what was called a set default policy on the user initially. So what could happen is Sarah will be sent to another department, and they'll probably re-permission her to go to have this department have this department's permissions, but not the last department's permission. So what Sarah can do if she wanted to go back and look at the last policy, the last permissions, she could run the set default policy on herself through the AWS command, and that will revert her to the old policy where she had the original policy, and she could go back to her old department information. If we could find other users that have this set default policy on there, we could potentially leverage this to get access to other areas that we didn't have access beforehand. So this is something that I've exploited quite a lot in the past, and it's something that a lot of people who are developing AWS or applications or structured services don't realize they have. AWS has an instant metadata service. It's basically like an API call where it'll provide JSON information of the running services right now. So basically, like a serverless function, like a Lambda function, could call this metadata service function to get a new session for itself based on its role, or to see what's running on itself. It's only accessible to the IP addresses within the Amazon instance, and it's usually always starts with 169.254. So what we are going to do is we're going to leverage other vulnerabilities to get access to this metadata service, because this metadata service is what we're going to is what we can use to get live credentials onto a certain resource. So this is the typical structure, one of the typical structures of this metadata service. And it's not documented by AWS because they don't want the bad guys to really get this. But it's basically what I call an open secret nowadays. If you were to go onto like an AWS or an Amazon cloud into the network, and you're able to call this URL, it will basically give you the live token right now they could use onto the service. We will see the username, we'll see the password, and the session with the service. What we want to do is, once we get these informations, we could actually use the Amazon command line interface or the tool itself to create our own profile or our own user to access the service on its own. And the reason why we do that is, when we create our own user and our own profile that looks like has legitimate access, it's going to be a little bit harder for the blue team to actually see that this was accessed, because it looks like a legitimate user is accessing this. A permission user at that is accessing the Amazon instance. So this is back on the serverless function. Where I mentioned this earlier. These are basically they run once in their call and once needed. These are basically service calls, and I said we'll be able to use these functions to pivot to another point. Oops. I wanted to get this slide to show you the different terminology between AWS and Azure, and I'm using these two because these are the two prominent ones I've seen. There is also Google Cloud Computing as well, and Alibaba's coming up with one of them, but I haven't had much experience with them. But these are terms that we've all seen quite a lot. We could probably see a lot while doing these testing, or probably by even signing into our own enterprises. So the EC2 for AWS will become Azure Virtual Machine, the Virtual Private Cloud will become Virtual Network, and so on and so on. So as you can see, AWS has AIM, where Azure has Active Directory services, or Azure Active Directory services, which is different than the standard Active Directory services they see on an on-premise site. Okay, so as I mentioned earlier, one of the main entry points to the cloud infrastructure or enterprises are web applications, and even web applications that access VPNs, such as Cisco SSL VPNs have web interfaces to access the internal network via a web application. There are several. We're going to use these types of applications to leverage vulnerabilities to get further into the cloud. I will show an example of how I use server-side request forgery to actually get that metadata service credential. So last year during engagement, we were scanning an internal cloud, and I noticed that we were scanning an internal IP address range, and we noticed that there was an instance of this Grafana cloud deployment. We saw something like Prometheus and other types of metrics. This was like a metrics reporting platform. I really don't know exactly what it does. From what I saw, it looked like it was like an observation platform, or it was definitely some kind of reporting platforms that system admins or internal people use to basically gauge the usage of the cloud. But we noticed that there was a function there that called another URL. So what I used to exploit mainly as open redirects, I can now use it as basically a server-side request forgery. So it's in this instance, instead of redirecting to an arbitrary site, I decided to redirect it onto something internal. So what I did was I noticed that I went to the vulnerability that was described here, CVE 2020 1379. It described the server-side request forgery instance that I'm going to describe to you right now, show you how it worked. So what it did was it took the avatar parameter, anything after this avatar session, it could put anything in there, and you can have it redirect to one site. And then if you change that redirection to another site, you can have it then go to the meta service, the metadata service, which is what I've done over here. I attached the metadata service IP address onto the redirect here, and this was the result. Here we were able to get the access key ID, which is basically the user of the application, the secret access key, which is like the password, and the live token. These tokens are usually by default are good for 6 hours. So if this token is not refreshed or anything after 6 hours, you can always come back here to leverage getting these credentials, getting these sessions, and then creating a profile with it and installing yourself onto that service. So this was something I've seen in a while several times. It's something that is a quark with AWS. So one thing that's often overlooked while on deploying these applications or services is that they rely on API communications, and oftentimes these APIs could be overly permissive to get information from other places. So they may want one API to call billing, to go call, as well as the same API to go call, say, provisioning, or maybe call some other department. So if you rely on certain APIs that could have access to these different departments, then you could potentially use the same session from the API to go access another session, to access another resource. So one thing I found is if I were able to get a token from one API that called, say, billing, I was able to use that same token via a user that didn't really have access to provisioning to then provision another user onto a system. So that is one example of how we could how APIs are exploited. What I've noticed in the wild often a lot is that APIs are often overlooked in this fashion. I was often able to basically get information from these APIs because the API session itself is always valid. And oftentimes when you're using a web application that has an API, they want to tie a web application session to the client or a GUI that calls the API, and the API has its own session. So while you're using the client or the application, you yourself may think that there's a roadblock here, like it may gray out all the buttons for you, or might prevent a roadblock in a step. But the API has its own permission, its own token. So you can still make a call using an API token to a service and get the results back in like a JSON response instead of going through the GUI, going through a web application GUI. And this is something that is still being it still has to be checked and across a lot of organizations, because I've been able to gain a lot of information from lots of information via API leakage and improper access controls on APIs. And a lot of functions in the cloud rely on these APIs where there's no GUI, it's server to server or app to app or function to function. And these APIs are often overly permissive. So that's the conclusion I have for this right here. I want to open up for more questions and answers. I didn't want to get too technical into this and give too many technical details, because I could figure that might be too boring or too excessive. But I'm open to any questions or statements you have regarding enterprise testing or cloud-based testing.
What do you think is next? Oh, sorry.
Yeah, go ahead. Go ahead.
Sorry, I got ahead of myself. This is just like an interesting topic to me. So what do you think is next for enterprise penetration testing in cloud?
Well, I see a lot of organization going towards Azure a lot more and AWS. What's going on next is, as we're getting more and more resources into it, we're going to see a lot of default configurations spun up, and we're going to see a lot of these similar things I just demonstrated here, like the metadata service exposed. So I expect maybe later down the line they're going to have more defaults that are more secure. But I do see a lot more people probably going to a Google Cloud platform as well. Alibaba might make a stake in Chinese environments, Chinese companies. They're already starting to have their own cloud services there, and they look a lot, I believe, a lot like Google Cloud Computing Services. But I do see more organizations going towards more of a hybrid model, or where they have on-prem stuff and cloud stuff, to even more flat out of a cloud-based model. And I do see we're going to see this a lot more in the future.
As a follow-up, do you see organizations kind of outsourcing this kind of penetration testing, as I've been seeing has been trending, where like you might have like a PM that manages a few people that are in a team but aren't in the same country? Is that something you see happening?
So I've seen it happen. This is how I've seen it in my field. Where I work, they have me do pen testing on enterprise and on the local enterprise or internal systems a lot. They have me see if I could do ransomware or stuff like that, or anything against the cloud. They also hire third-party vendors to go do assessments as well. vendors such as IBM, Mandiant. I've seen them. I've actually overlooked them doing the testing as well. And I see them come across they use testers from all across the world sometimes. My team, I have testers in other countries. I have a tester in Canada as well. I don't really think that really makes any difference in the actual work that's being put into it or what the results that's going to come out of it. But I do see more requests being done for these types of testing, especially on their implementation of certain instances. So I have seen calls, a lot of people making requests for Office 360 testing or their own SharePoint testing or their own implementation of things. I've seen that a lot, and I say it's a pretty big selling point for a lot of these third-party testers too. When I talk to them and have conversations with them, they have to have multiple testers or people on it, and I've even seen these engagements go up to about 3 months long. So some of the engagements, if it's like a full red team assessment that includes social engineering and stuff. So I definitely see this being sent to internal teams a lot for certain things, and being outsourced to third parties as well, just for some expertise in it.
Thank you. I guess I can keep asking questions. Okay. So what are some of the juiciest bugs you've seen? Besides some of the, I guess, the more common ones that you just showed us, that you've been able to discover?
So let's see. So I was able to exploit identity access management of a customer from enterprise. Basically, I was able to pivot from a customer's API access token to get into essentially a customer care representative's terminal from the outside, basically from the external facing website. I'll give the example of a Tesla.com. It wasn't Tesla.com. Let's give that example. From the external facing website, Tesla.com, I was able to use the API information, the API calls from the IAM to go pull records from from basically the billing department as my own user, basically via exploiting the improper controls over IAM. I thought that was quite interesting because at that point I was able to get a full info just by enumerating customer IDs. And I thought that was quite interesting to do. And what was also interesting was that when I was able to do that, it didn't look like it was a bad request. It looked like a legitimate request. So I was able to work with the development team or the not development team, but I was actually able to work with the SOC right then and there to have it fixed right away because I was able to actually get credit card numbers and a lot of PII information that we shouldn't have gotten, and we closed that bug down within about 30 minutes. So I was able to get that pretty quickly, and it was quite scary too.
Yeah, for your AWS trick, I thought AWS versioned that API so you could get a new version where the first time their daemon started on the virtual machine, it pulled a one-time token. And if that daemon ever died, you could never access that internal API again.
What was that? Like, is that something you've seen?
I thought it was something they did already, but I'd have to find a URL or something referencing it. Because
So
they got
they
tired of people going after that.
yeah, so they have tried to do that in version 2 in version 2, but so the way what happened is they tried they did it in version 2. They tried it what they did that reset, but I was still able to see this in the wild, and I still use the same old methods. I was still able to do it. All I did was I created a profile and I kept on calling that call, and it still gave me a new token. I haven't actually seen it implemented, but it stopped me from that in a while yet.
Here's a another question that if you have any resources for exploiting AWS API vulnerabilities or any white papers you can recommend.
So this resource I got for this presentation, I got from the I already got from SANS, their cloud computing training. Other resources, I don't really know off the top of my head right now. To be honest.
Which SANS one? The one that Moses teaches?
Yeah, the one that Moses teaches. Yeah, Moses.
Oh, that's awesome. Yeah, guys, Moses is sometimes and the Discord or Slack, so you can actually reach out to him directly. That's awesome. What's the number of the course?
It's 588.
588. Awesome.
Yeah. So I gave with this presentation I gave basically a portion of that training. I condensed it a lot. I didn't want to completely like rip this stuff off as well, but I also put in my experiences with actual testing of enterprises and cloud-based systems. And in my experience, I was actually surprised because like when I was testing cloud-based systems before I took this training, and when I saw that metadata service thing in the wild like that, and I saw it was basically a textbook example in the training itself. So I thought that was kind of funny to see that. So, but I was able the stuff I've got from really the API testing and everything. I got all the my training just by hands-on testing.
It's pretty good. Any CTFs that you know of? There was a question before.
No CTFs that I really know of. I haven't really followed CTF. I followed CTF in the last 2 years, so I haven't. My CTS have been, they've been giving me a real life one, so I haven't really had to play with one.
Here's another question.
Yes. Yeah, if cloud clients actually follow the rules, a lot of these will go away. I mean, if developers follow the rules, a lot of these will go away too. But things that wouldn't go away are inherent things such as, for instance, if they still had resource policies where the policy allowed the person explicitly go into it, that could still allow things. And if someone actually knows the command line tool of AWS, they could, even though everything is set up properly and you did everything right, you could still get a compromise. Say if I was able to steal somebody's password or phish them. And as I said, like 90% of the infiltration that I've seen in the wild has been straight up phishing and social engineering. One of the most recent phishing campaigns that I seen was successful was they used a Toastmasters template to get some Toastmasters people to go click something. So it could even be groups that you're part of that they could go fish a template out. Other social engineering aspects that I've seen in the wild are LinkedIn recruiters trying to send you a document to go show them, oh, here's a new offer. You have some nice pretty lady on LinkedIn showing you some offer or something. You click it potentially on your work computer, and now that could be a source of infection right there.
James, in your experience you know, and working with some of those other companies that have also done testing alongside you and your company, what did you find, if you had any knowledge to what they found versus what you found, and what was, you know, who found more, and tell us about that.
So in my experience, I've mainly been on par with the third-party testing, or I've often a lot of times I found a little bit more than they have found. One reasoning behind that, and that a lot that my managers and people have told me, is that because I'm internal, I have more at stake to do a better job and finding stuff than say a third party, because you know a third party probably won't care as much as somebody internal to it. So, however, you know, I have seen some novel things that some third party has done. So I have seen IBM, for instance, they were able to write their own tool to extract Symantec VIP tokens once they were able to access a client in real time. And then they were able to access the VIP tokens from memory as well. I thought that was a pretty novel thing that they actually wrote a whole tool to exploit that VIP access, the Symantec VIP token. But I would say, you know, I was actually quite surprised, sometimes a little bit disappointed, because I really a few times I've hired some third-party testers or third-party vendors to do some assessment, hoping to find something novel that they've done, and I haven't really seen much anything more novel than what I just showed you right here. And even when I do it, I still pull out a lot of things. So I mean, I was quite surprised that a lot of things that I think should be easily fixed, that you know, by basic security, are still out there and easily exploited. Also, I've also had experiences where a third-party vendor did not do their job. When I first came to an organization, they were hiring this third-party vendor where all they really did was ran a scan and printed out the result. Didn't even go over the scan for false positives or anything, and they charged the organization 100 grand for that. And I thought that was appalling. And I came in there, I did the same test, and I found so many things wrong that they had to fix right away. So it's also has to come on the awareness of the organization as well, to make sure that they're not being hoodwinked by some of these third-party vendors. And I believe that after I got in there, and after they got a more developed internal team, we were able to look at better third-party vendors and see better reports out of them.
Any other questions?
I do have another one. You know, it's my impression that, or what have you found? Have you looked in the areas of orphaned instances, and what did you find?
Basically, you mean like VMs that were no longer being like looked after, or that are no longer, like, for instance, like they're no longer part of a group anymore? Is that like what you're referring to?
Yeah, it's my impression that, you know, a lot of people probably aren't really keeping track of their, you know, instances very well, because they've got, you know, so much.
Right.
And that's a source of vulnerability that needs to be highlighted as well. And I was
Right.
just curious as to how much you saw, or even did you have an awareness to look for it?
So in my personal experience, I've experienced being an orphaned person out of the Azure directory at one point, where they had me outside of all direct, they had me as my own department at one point, which was interesting. But now when it comes to orphaned or orphan resources, that really depends on the asset management of the organization. I've been to some organizations where they had a full overview of their assets. They knew exactly what each host was, what was spun up or not. I had organizations that had a somewhat of a decent view, and I've seen organizations where they had no idea what was going on in their own internal network. So in those organizations, there's going to be a lot of orphan things. I've seen many times, applications or services that are completely demo applications that the developer spun up, to see if something worked, and forgot to spin it down. And these things often are ripe with are full of vulnerabilities. One thing I've seen like an internal EC2 instance that had like an application that I think the developer was working on for college or something. It was completely unrelated to the organization. It was like a book selling invoice app, or maybe it was something to train himself on something. But this application was a PHP application that was calling a system function that I was able to basically exploit this application that nobody knew about to go pivot to another box, or pivot on this same box higher privileges, because some developer wrote something up to test and just left it there. So it really depends on the organization's asset management and their monitoring of what's being up or down there. Orphan instances or orphan things could definitely be out there, and if they're not using any resource or any utilization, they may go unnoticed for a very long time.
Any other question? All right, I'm gonna hit stop recording.